Hello, everyone. Good morning. My name is David Talby, and welcome to this talk around natural language understanding and what you need to know when you're looking to start or grow projects in that space. If you have any questions, please use the feedback from audience and questions from audience link to share them as we go. Some questions, if it's kind of relevant within the section, I will answer immediately. Other questions we will save towards the end. So overall, natural language is definitely emerging as kind of the next big thing after imaging, after understanding images using machine learning and deep learning. And within the past really 2-3 years, NLP is kind of having its moment in the light in terms of both the level of accuracy that new deep learning techniques are able to get to, as well as the level of applications that are now really becoming available, because we can get to levels of accuracy and scale that were just not feasible before. So really, I mean, you can see from these examples, we have Google Translate, we have automatically reading legal contracts, automatically reading patents, automatically doing communication surveillance for better and worse, looking through emails, IM messages, speech translation, looking at customer service use cases, and you can see on the left that's a lot of what I do, so I'm just more familiar with it myself. A lot of work in the medical space, looking at clinical notes, pathology reports, radiology reports, clinical trial research, claims, and other kind of say more text-based data items. And of course, we've had the chatbot kind of revolution as well, and there's more and more that's happening this way right now. So it looks like that if machine learning started with structured data, and then we moved on to we really done fantastically well with images. Now it's getting to the point where it's really becoming much easier to do things with free text as well. As many applications as we see nowadays, the one thing to know about natural language understanding is that it actually, I mean, it's a fantastically hard problem, and it's one of the few problems that that have reached kind of the status of what's been lovingly called an AI-complete problem, and it's a wordplay on NP-complete problems in computer science, basically saying that a problem would be called AI-complete because, in the sense that if you've solved it, you've essentially solved hard AI, right, or general AI. Because as humans, most of the communication we do is using language. And we don't only use language, we also, we play music, and we do paintings, and we hug, and we have other ways to communicate. But by far, our best and more complex means of communication as humans is language, right? We speak, we read, we write. So there's bold consensus that if you can really understand all the nuances of human language, you've solved strong AI, which really means that we're not there. Okay, and we're very, very far away from getting to that point. What we can expect, okay, is what we can expect for most machine learning, deep learning, kind of the AI labeled systems today, which is you can match or exceed human performance for very, very specific tasks. Okay, so if you want to extract specific facts from a customer service email, or from a phone conversation, or from a legal contract, or from a medical record, you can definitely expect to be able to do it very well, of course, given the data and given the right technology. But obviously, we're not talking about being able to replace humans in any, in the foreseeable future. So the goal of this talk is to talk about lessons learned building actual real-world systems that do exactly that. Okay, meaning we talk about natural language, meaning free human speech. We want to have systems that can understand in context, in a fairly deep way, specific things and answer specific questions, and talk about how we do it. This talk is not is an executive briefing, so we're not going to go through the details of how you define layers of deep learning networks. We're going to talk about three main lessons learned that I think if you are either engineering leader, data science leader, but also if you're a product leader, a CTO, CEO, those are things you need to know as you're planning those kinds of projects. So the first and most important thing to know about NLP, and something you should think about when you're planning actual projects, is the following statement. All of us on a daily basis speak many more languages than we think we do. And I'm not talking about only English, Spanish, Russian, German, Portuguese. I'm talking about the many variants of language used to communicate on a daily basis. And I'd like to walk through some examples just to show what the complexity here means when you're looking at a kind of a real use case. So this first example is from a CRM, a customer relationship management set of notes. And this is from a commercial real estate example. And the goal here is to see if we can build a system that reads the text and extracts kind of customer qualification questions. Okay, so looking at the latest notes that the agent or the salespeople wrote, who seems to have the budget, who seems to have the authority, who is actually going to buy soon, where do we need maybe an executive to get involved, right? What's the likely time to actually get a sale here? And what you can see if you look at the text, you have examples like, set a tour, looking for 5 million in the in the cap range, interested property tour, the client needs to put in an offer, or we can have some just emails that are copy pasted. So what you can see, and this is fairly typical, you see text, they are in natural language, they are not complete sentences. They very much assume context. So if I say looking for 4,000, there's a question of whether this is money or square feet and what the units are. And really, unless you're a realtor or an agent in that space, it's very hard to understand what this does. So intuitively, look, if someone is putting in an offer, they're much farther along than someone who just want to set up a tour. But this is kind of only something you'd know, if you're kind of within that business. So the problem here is that the grammar is different. There's very specific vocabulary that's localized to this team. And you need to understand, you don't need to understand English. You need to understand commercial real estate leasing to be able to really answer the questions that the customer actually cares about. So that's one example. Take it to a different context. Let's say now we need to read academic papers. Okay, academic papers are fairly structured. You have the titles, you have the authors and the affiliations, you have an abstract. And even the paper itself is usually organized. You have an introduction, you have background work or related work. Then you have the experiment setup, you have the main results, a discussion, and then a summary and references. Now, let's say we want to be able to read all of the recent academic papers, and do things like look for example, looking for clinical trials. Like, is this a clinical trial? If so, what stage of the trial are you looking at? Was this a double-blind study or not? What's the sample size? Did they publish all the results or only some of the results? What was the benchmark they used? So those are things that would be in free text within the paper that you want to be able to extract. Now, in this case, in order to do this, you need to understand for each of those features that you actually care about, how are they often described in an academic paper? You definitely need to understand the structure. So you need to know the title has a lot of wordplays. The abstract is kind of a very good summary, kind of manually curated summary of the main kind of paper, the main keyword and main outcomes. You need to know that introduction-related work probably is actually not that relevant if you care about this paper, because it talks about other things and so on. Compared to the previous example, here you would see proper English, meaning the sentences would be grammatically correct. Okay, you see, you'll see longer sentences, and you'll see kind of proper English. In sharp contrast, if you look at text messages, you have a very different language that's been used. So first of all, you do not use complete sentences. You split sentences into different messages that go one after the other, just for the convenience of hitting send sooner. You don't need to say, basically who is speaking to whom, because that's implied in the context, right? So often kind of the subjects and who I'm speaking about is only implied. You have autocorrect and you have kind of certain type of spelling issues that happen, you have emojis. And if you think about it, emojis are basically a language whose only purpose is sentiment analysis, right? So telling you how I think about something that just happened. And for example, another thing that happens, when you use profanity in text messages, very often it's in a friendly way because these are two friends talking. So profanity in text message actually means that two people are closer. While if you do the same in a customer service scenario, obviously profanity means something completely different. It usually means real anger. So that's another case where if you want to read this text, you need to know that you're dealing with SMS languages from the tokenization, sentence breaking, part of speech tagging, understand the dependencies, all the way to understand kind of the meaning. Right? If you're looking for sentiment, you're looking for semantics in a different way than the examples we've seen before. If you look at a different example, looking at legal transcripts. So legal transcripts are very long and very useful documents that are basically the verbatim conversation as recorded in the courtroom. So every time someone says something that gets recorded, there are actually specific signals in terms of dashes for pauses in speech or for talkovers when someone talks over someone else and interrupts them. So one thing you need to know if you're trying to say, for example, you want to build an application that looks at all those transcripts from the past 5 years and give me a nice dashboard about who is the more difficult or more lenient judge for specific type of offense. Do we seem to have a bias for specific genders, age groups, ethnicities? And if I'm going in for a specific kind of type of hearing, what time of day, what kind of judge, where would I be, where would I have my better chances, for example. So in order to understand this kind of transcript, first of all, we need to understand just the text, the fact that we have someone who's speaking and then we have this kind of dialogue that's been described. But the other important thing is that you have to understand the procedure. So if you don't understand that this, like in this specific example, and this is a public example from the internet, we are looking at a hearing to suppress evidence. If you don't understand that this is a hearing to suppress evidence, and this is the procedure of this hearing. So we start, prosecutor goes first, presents evidence, then presents witnesses, then we go to the defense, then we have another round of questions, and then we summarize. If you don't understand that this is a protocol, it's next to impossible to understand why people are saying certain things and what it means in that context. Okay, so here also, starting with just how you parse the original text, how you break it into sentence, how you tokenize it, how you do dependency parsing, all the way to the semantics. Okay, how do I build a classifier for what kind of hearing this is and what was the result? You need a domain-specific example. And there are definitely more examples we can go through. Emails is another example. So when we use emails, the language is its own language. In general, we do use sentences, so it's slightly more formal than when we speak, slightly less formal than when we write papers. Obviously, emails have their own, there's replies, there's forwarding, there's the threads and the replies. And the other thing to know about emails is that the string that you actually have to parse when you get an email looks something like this. Right, so you get really most of the important things are often just in the metadata itself. Okay, and this is another thing to remember when you are building your own NLP process. Oftentimes, the string that you're actually processing and you need to write custom code for is going to be very different than what you would send whatever NLP library you use. And this slide just really one last example from sports, because I found it funny. People actually build classifiers for things like, goofy remarks, local color, local language. But if you're looking at sports, and for example, let's say you want to build a program that automatically listens to a radio broadcast and just translates it to just the current score in the game. So now someone scores, you can just update the score within your app. You do need to understand what is the game. How do people call out scores? Because if you ever listen to basketball versus football versus cricket versus baseball, you'd see that people even call out points in very different ways. So anything that you would read or try to parse in that context is going to be specific obviously to the sport. It's going to be very specific to the country you are in. And sometimes it's going to be specific for basically the style of broadcaster you're listening to. Okay, because when someone say scores a goal in a soccer match, the text is not going to say, oh, there's a goal and now it's 2-1, right? There's going to be a great variety of different ways where people will basically say the same things. So as a result, if you look at all of these examples, and these are kind of the primary interesting examples. In general, with an NLP problem, you have a text, people assume you can understand it. So you understand the grammar, you understand vocabulary, but then you can go deeper and answer those kind of more semantic questions. So, what is the score? What is the result of the hearing? What product is this customer complaining about? Right? What orders were ordered for these patients? Here's what you have. You have each one of them uses a different vocabulary. Okay, and really it's vocabulary in the sense that if you look at the distribution of primary words, they're going to be very, very different. Use different grammar. So if I'm speaking versus writing an email versus writing a patent versus writing an academic paper versus writing a text message, I'm using a very, very different grammar. Okay, and and if you don't believe it, try part of speech tagger, try coreference resolution, try dependency parser, and see that unless you've trained them really on this grammar, you're going to get extremely poor results. Okay, really in some cases, you do better with using an English part of speech tagger on Spanish text than using English parts of a speech tagger that was trained on, say, news on text messaging. There's different context, obviously, right? But because when we speak, there are many things we don't have to say. So when I write someone a text message, I don't need to mention their name or that I'm talking to them. And that's something that your algorithms usually need to understand. And of course, different meanings. So if you look here on the right at the list of really algorithms, kind of NLP tasks that we need to write code for, they're very different by context. So the first thing that you should be aware of when you're building your own NLP project is that in all likelihood, there's a specific language that you need to build models for, and you need to plan for it. Okay, meaning assume you need enough data, enough label data to understand that language. There's usually some transfer learning you'll be able to do from other things, but do assume that you need to build custom models. So we just talked about some examples and kind of the first, what not to do. Here's how you would go about it. And the second thing you need to kind of have in mind is that, here are kind of the three pieces you need to have a successful natural language understanding project. You need to get a domain expert. So get a lawyer, get a doctor, get a customer service specialist. You need to get a data scientist because you will need to build custom models, and of course you need the data. So one of the first questions that people often ask is look, why can't I just use off-the-shelf NLP models? Okay, there's Spacey, there's Stanford NLP, there's Amazon has solutions, Google has solutions, Azure has solutions, there's open source solutions, there's NLTK, there's GenSim. Why can't I just the software that says, look, here's a name entity recognizer. You just send me the string and I send you the entities. And there's a really simple answer for that because basically it just doesn't work. And to make it more data driven, really, you should not believe me, and you should just test it for yourself. Here, and this presentation is available within the attachments and links. There are six links here to user interfaces, and the only one that doesn't have a UI is Amazon Comprehend, but then there's the link to the API and the product. With the other ones, there's basically a user interface where you can open a web page, type a sentence, and see what the result is. Okay, and this is probably the first thing you want to do. Try to look at all of these tools, and these are kind of the the most widely used ones, either by the open source community or the kind of the cloud-based vendors. To kind of say, oh yes, of course we do sentiment analysis. You just a web service. You send us a string, and we give you the result back, and you can use that for entity recognition, entity resolution, dependency parsing, a whole set of tasks. And really, the first point I would like to make is look, I would say I'm almost yet to see a case where people were able to use these off-the-shelf pre-trained models and get really kind of results that they went to production with. It's very good for experimentation. It's very good to get some initial results. It works decently well in some cases, but usually it's going to be either completely off or very far from what would actually work for you. So that is definitely, I think, something you can do kind of for the first day when you're evaluating the project and you're still trying to estimate how long things would take and really who you would need on it. But that's kind of one of the most common mistakes that I see projects make. Here are some examples. So one example here is a medical example, and these are actual notes de-identified from people going to the emergency room. So you have, if I look here, for example, the second example, since yesterday, 10/10, constant Tylenol 1 hour ago, plus nausea, diaphoretic, mid-ABD radiates to back. So this tells the story of a patient that since yesterday, 10 out of 10 is a level of pain. In this context, constant Tylenol 1 hour ago is presumably the medication they decide to take at home. Plus nausea is, that's a kind of grammar you only find in medical notes saying that the patient has nausea, diaphoretic means that they are sweating. Mid-ABD radiates to back means that they have a pain in the abdomen, so the middle section, it radiates to their back. If you look at all of these notes, so here's something that you see a lot in healthcare. None of these sentences are kind of grammatically proper English sentences. Okay, so they're just not proper sentences in English, none of them. Meaning that your sentence segmentation, part of speech detection, dependency parser, off-the-shelf would probably not work. None of them mention the word patient. Okay, and that's very common. That also happens a lot in social media, where you basically you dismiss or you do not show the subject of the sentence. None of them mention the word pain. Okay, because it's obvious from the context. You don't go to the ER to for the free TV. But the other thing is when I show these notes to to friends of mine who are physicians, they look at it and say, "Oh, these notes are fine. That's exactly what we need." So from a human perspective, this is the right level of detail and context, right? Because when I'm in the ER and I go to a patient, I don't want to read a long story. Just give me the details and I go from there. So from this, what we're looking to extract are basically, okay, what kind of pain is this? Like, where does it hurt? How much does it hurt? When did it start? What's the body part that's hurting? And did you take anything at home so that I don't overdose you? In order to be able to understand those sentences and extract those features, right? So that's the actual understanding I care about. Obviously, I need something custom. And specifically, if we look at the top, the 6 kind of NLP engines that I showed you in previous slides, which is really kind of the most popular one probably today. Basically, they completely flank on this. We're basically only 2 of the 6, and I will not tell you which 2. You can definitely test it for yourself. Recognize one thing: they recognize Tylenol as a product. Other than that, none of them recognized any symptom, any diagnosis, any drug, any measurement at all. Okay, and those are kind of the things that first surprise people at the beginning. They go and assume, oh, well, NER, that's a solved problem, unless you're dealing with your own language, which is very often the case. Here's another example of why off-the-shelf models are often problematic. And this is a case where this is a sentiment analysis case, where we're working with a company who's looking to understand social media posts. Right, and this is one. On the top, you have a news example. At the bottom, you have a Twitter example, and try to provide real-time intelligence for trading, so for financial trading of assets. Okay, and basically the goal is to kind of say, look, if we can see quickly that someone is tweeting or when news just broke that may impact the company, so executive departure, new announcement, new regulation in the industry, new weather pattern that impacts them. If we can react to it correctly faster than others, we have a leg up in terms of making more money and trading better. So what this company tried to do was saying, okay, we already have time series forecasting models that do not use language. Right? So there are many other signals other than language that's going to predicting the price of of an asset. Let's see if we can add language. So let's just do this. Let's collect tweets and news announcements, send them to a cloud-based sentiment analysis model that's pre-trained. We get a signal from it, and we understand the signal may be noisy, right? It doesn't have to be 95% correct. It doesn't even have to be 75% correct. But basically what we do, we feed it as another feature into our time series forecasting. We'll train it, and we'll see if it works. Right? So if it gives us any lift, right, that's already kind of a good quick win. So this started with Watson, which has actually a decently good kind of pre-trained sentiment and emotion analysis model. And after a few months, they had zero lift. Okay, meaning that basically what happened was that the sentiment results they got from Watson, when they fed them into their model, the model just completely ignored them. So basically, the model said, "Look, there's no value here. There's no information." So that resulted in investigation, which basically came up with the following, and this is fairly typical for sentiment analysis models. Most of the pre-trained sentiment analysis models you will find online are trained based on customer service scenarios. So in customer service scenarios, the main features, right, or the main signals for either positive or negative sentiments are emotion words. Okay, so if someone says, "Oh, like, thank you, you've been a blessing, you've just helped make my day, thank you for your help," that's very positive. If someone says, "Oh, this is like the worst company, I'm going to sue you," and expletive, with kind of angry words or profanities, that you're very much in the negative. But the thing is, when you look at financial news does not use emotion words. Okay, if you look even at the two examples here, like unless you're an industry insider and you understand the impact of what people are saying here, you're not going to see anything, right? So all of these split and classifiers would return neutral sentiment for both of those examples, and those are actually examples that caused respective stocks to jump by like 10 to 15% of the day they came out. So in the financial space, it's more about the reputation, about who is speaking, right? So is this an analyst or someone that's respected in the industry, right? And is this a change from the previous prediction, right? So if I said buy before and now I say hold, that's a change, that's important. Okay, but and that's something you need to know about. So basically, it's another example where basically the context and the meaning of words completely different. And what had to be done here is basically train a completely different sentiment analysis model that basically tracks what sentiment means in the context of recommendations for training of financial assets, which is very different. The opportunity here, if you're building those kinds of models, is that, and that's something you definitely need to keep in mind as someone who owns the product, owns the technology, is that once you build this model, you actually have new proprietary intellectual property that's interesting. Okay, because if you have a sentiment analysis model that can actually understand, for example, news and training sentiment in near real time in the financial sector, that's probably something that others do not have, right? Whether they claim they've done sentiment 100 times or not. So we agreed on the fact that you probably need to train your own models. The next thing that you need, next to your NLP data scientist, so someone data scientist who actually knows how to train NLP model, is a domain expert. So someone who really understands the language. Okay, and that's the next mistake that most projects make. They assume that labeling data or annotating data would be easy or would not require specific expertise. So either can be crowdsourced or can be something that kind of we do on the side without much thinking. But it's often harder than it seems. And of course, we can go into cases where you need kind of years of experience to be able to understand what something says, like the medical case. But you also get those issues in much simpler cases. So for example, let's say you're looking to label reviews. Okay, so we have customer reviews that are written in text, and we just want to have a model that just translates the text into a 1 to 5 star rating. Okay, so people can see the stars and you can sort by them, and it's just an easier thing. So if you look at if you look at an example like this, if you come for the ambience, you'll be disappointed. But if you go for good, inexpensive, and authentic Mexican food, then you're in the right place. and this is an actual review from Yelp. And then the question is, okay, is this a 3-star, 4-star, or 5-star review? Or could be 2-star as well. What would happen here is that if you give it to multiple reasonable people, they will disagree. And one of the main issues that you get, if you kind of just assume that, yes, this is easy and we let a bunch of people do this, is what you get in most cases, you get fairly high disagreement rates. Okay, and here's what you need to understand. If, let's say there's a 20% disagreement rate, okay, so meaning in 80% of the time people agree, right, on what the result should be, but 20% they don't, it means that 80% is the absolute upper bound on what your accuracy can be. Okay, because anything that you get in terms of accuracy, it's above 80%, it's by definition, you're overfitting basically to random signal. Right, because above 80%, it really depends on who you ask from the team. Right, it's essentially a random noise. So anything you get above 80% really means that you're overfitting to the data. There are quite a few cases, like review labeling, sentiment labeling, and labeling of cases require kind of specific domain expertise. Okay, like for example, legal cases, we can easily see, you can start off with 60 or 70% agreement, which makes it very hard at that point to get to an accuracy that's going to be convincing anyone to use the algorithm later on. Okay, so just as much as you're investing on making sure you have the right NLP data scientists on the team, make sure you actually have a process to make sure you have a kind of labeling that's consistent, that covers edge cases, and has some process to resolve disagreements. Right, which really could be as simple as just having people speak as they speak with one another every few days. So I have a couple of examples. So one project we've had to work on earlier this year was looking at understanding pathology reports. So pathology reports happens every time a biopsy is taken, sent to a lab, and then want to see basically is there a potential tumor here or is this benign? And if so, what the properties of the tumor are. And this was one example where we thought the challenge would be actually extracting building models to extract facts, like tumor size, tumor location, grading, staging from the text. Actually, more than half of the project was just to agree on how to label things. Because apparently in oncology, there's a lot of clinically important detail that goes around how you define the size of a tumor. Okay, so do you include the edges, do you include the axis, what is the primary, and what is the secondary? There are a lot of questions how you define the location of a tumor. So traditionally, it's the biggest tumor or the first one, which is often how to determine. What if there are multiple ones? What is kind of the body part that you mentioned? How do you determine staging? And there's a lot of detail there that actually has clinical significance. So really, we got to a point where more than half of the actual project was around really just having a small team of pathologists correctly define what the correct labels need to be, and only afterwards we were able to have reasonable label data that was consistent, and then really training the model themselves was by far the easier part. Here's another example from a different domain. So if you're in the legal space, you may be familiar with those two cases. Those two cases are basically the two precedents that in some ways form the basis for the e-discovery industry. Okay, until about say 10 years ago, if a company sued another company and said, "Oh, we need discovery. You need to send us all the emails, discussions about this product or patent because we are claiming that you stole it from us." People would send millions of pages of documentation, and then you'd have literally tens or hundreds of lawyers reading them one by one. And then as an industry, we decided, look, why don't we just do this? We have a list of keywords. We'll put them in a search engine, and only the emails or documents that match those keywords would actually get sent. Okay, so that it's a far cheaper process for the company getting prosecuted, right? Or they need to actually provide the documentation, and it probably also helps the receiver as well, because there's much less noise there. But then the question was, okay, it's a legal question, which really came down to a labeling question, which, okay, how you define this algorithm, right? So, and how do you make sure that you don't have this kind of black box, ranking or search information retrieval mechanism that actually enables me as a defendant to hide facts from you. And those are two cases where basically you had lawyers and judges go on for quite a while to really define kind of what's the proper way to use digital e-discovery tools while still making sure that you're actually fulfilling your discovery requirements. Another question that happens very often is, okay, how much label data do I actually need? And the answer is, of course, it depends, but here are some guidelines of what you need to think about. So the first thing you need is you need to make sure data is actually representative. Okay, and if you look at some of the public examples on image analysis, so that they've had to actually label a large number of examples. For example, if you're looking to understand pathology reports, you probably need tens of thousands of examples because intuitively, if you only have 4 examples of stage 3 lung cancer, you're probably you're not going to be able to learn everything from just 4 examples. You probably want hundreds of examples for each gender, age group, staging. Okay. Similarly, if you're on a customer service use case, make sure you have good representation of every geography, every kind of customer that you have, every demographic of customer, and all the products you're serving. Okay, so often this is how to quantify, but very easy to intuitively estimate. So you need to make sure data is representative, does not have kind of non-biases. The next thing is to actually get consistent labels. Okay, and we just talked about some of the challenges and pitfalls in getting labeling that has high agreement rates between your judges, between your labelers. And the third thing you'd want is you'd want to enable some transfer learning. So things like word embeddings, reference data sets, pre-trained data sets, they exist for most domains and most types of problems. And while you still need to train your own models, in most cases you do not have to start from scratch. And in most domains that are kind of pretty good, free and open source, at least word vectors, if not dictionaries and ontologies, and you can start with. So it's not an exact answer, but those are kind of 3 things to think about when you're trying to plan for either kind of the effort, the estimate, the time, the money it will take to get the label data that you need. Okay. The third and final thing I'd like to talk about is how do you actually use NLP libraries and NLP tasks within a real problem? Okay, because let's say you can do name data recognition, okay, or you can do dependency parsing, or you can do even sentiment analysis. Usually, that's not what you really care about. Okay, so what you care about is answering a question about the text. Okay, so if this is an email, I want to know, okay, is this a meeting invite? And if so, who is meeting and when, so that I can kind of auto-generate that invite for you, for example. Okay, if this is a medical record, I need to know, okay, this patient, what's their diagnosis? What medication do I need to give? What lab orders do I need to order? In most cases, yes, you definitely want to use the signals from the text. But the other thing you'll want is you'll also want to use structured data. Okay, so it's a patient. If it's a patient, and you already know, you have structured data that says, oh, this is a 3-year-old female, right, with the history of type 1 diabetes, and definitely you'd want to be able to use this data. It will, to give you much more accurate results. So in general, there's this traditional split between structured data problems and unstructured data problems. In reality, what you do is you get some signals and features from unstructured data. Then what you want to do is add other features from structured data and build the best classifiers you can. Okay, so here's one example from a hospital setting where the goal was to look at patients who are sitting in the ER and seeing and basically deciding how likely they are to actually be admitted, and if so, for how long. So there is a set of structured data that you can use. So you can look at their age, you can look at their gender, you can look at their vital signs, you look at how long they'll be waiting, what kind of insurance they have. Those are good predictive features to suggest how likely someone is to be admitted from the ER. But all of those features do not tell you why they came in today, right? So they can tell you, look, this is a much older person. They already have other 3 conditions. They already have blood pressure and a heart condition and 2 other things. So yes, they're more likely, but it doesn't tell you why they came in that morning or that evening. For that, you need to read the note. So what you want to do is you want to be able to read the natural language note, extract the text, extract those features. Okay, like really, what's the type of, what hurts, where, when did it start, and so on. And then you want to build a classifier from the combination of those structured and unstructured features. Okay, and what we found, like this is an actual project we did, so we can't publish the exact numbers, but what we found is really combining the features was, it was more than 10 points better in terms of F-score than using only the structural and unstructured features separately. Okay, and that's a very classic kind of result. Another example here is also from the medical field. It's a very common patient risk prediction use case for detecting sepsis. Sepsis is a severe kind of basically infection that some people get often while they are within the hospital. And in this example, what's nice is that this is a published academic paper, so the results and the numbers have been made public. And in this case, by including additional features from unstructured data, okay, so they start with only the structured data and then they included additional features from the free text notes, they were able to increase AUC from 0.67 to 0.86, which if you're familiar with those numbers, this basically means going from a model that's basically useless, right? So anything below 0.7 is often kind of questionably useful, to 0.86, which definitely is considered state of the art in this case. Okay, and the reason this works is because if you look at anything with the medical space, most of the information is within the notes, right? So when you're sitting in hospital bed and the doctor comes in, and it's the first time they see you, they want to see the latest notes, right? They're not going to read your demographic and labs and the numeric data to begin with, right? Because the notes are what's most clinically relevant, right? And now really what's happening is that we have the libraries and we have the algorithms that enable us to extract and use these insights correctly within classifiers we need. So as one best practice, one thing you want to make sure you do to enable that is basically to make sure that your NLP pipeline and ML pipeline is basically one pipeline, one and the same. Because the way to think about it is as follows. You're going to have an NLP pipeline. So say you take the text, you tokenize it, you split sentences, you normalize it, you remove stop words, you recognize named entities, you do dependency parsing, you do negation detection, right? So there's going to be a step of things you do there. But then what you get as a result is a set of features, which you're very likely to feed into some kind of classifier, regressor, or recommender. So what you want to do is make sure that this entire machine learning pipeline, from loading the data, constructing the NLP features, constructing other features, and then training the machine learning model you're actually looking to train, is a single pipeline. Because things like changing your tokenizer, training a new named entity recognition model for NLP, that's actually feature engineering in your bigger pipeline, and you want to make sure you can experiment quickly. So one of the mistakes people sometimes do is they come, so I'm doing my NLP separately, I get my results, then I feed it as features. Okay, then what it means that any changes you want to do within your kind of NLP pipeline becomes this kind of harder to do external thing, sometimes with another tool set, another library, or another, sometimes even another team. And so I guess my main recommendation is make sure you're not in that boat, so that if you want to try a different lemmatizer, a different tokenizer, just any different NLP algorithm, this should be really as easy as saying, oh, I'm running a random forest, let's try a different number of trees. It should be a parameter that you can play with and adjust and see if it gives you better results. And this example is from the Spark NLP library, but there are a number of libraries that do this much better than kind of the more traditional separate NLP libraries that have been available. Some final recommendations about how to start on an NLP project, also from kind of an executive or product management perspective. So what you want is pick a problem where you can build an existing baseline model based on structured data. Okay, so for example, if you're looking, let's say you're looking at the customer support use case, and you want to say, look, based on an email or a chat that's coming in, I want to understand, how angry this customer is and how severe, where should I escalate, for example, this request. You can just start with structured data. Okay, so come say, just see, how many times did this customer call me in the past week? Okay, are they kind of a regular or premium customer? Are they a paid customer? How long they've been with us? Okay, just using that, in a sense, without even reading the requests, you can build a baseline model. Okay, that will give you more than 50%, so more than chance in terms of understanding how well you are. And then on top of it, now you want to add the unstructured data. Okay, so make sure you start with a model that, where you can do a baseline with structured data. Okay, but among those models, the models that where NLP will give you the best results are the models, the questions where if a human were to try to do the same task, they would just go to the text. Okay, so for example, if a customer service manager would get something escalated, we need to decide whether to escalate something. Okay, for a customer, the first question is not, oh, show me these customers, profile and how long they've been with us and how many support tickets they've opened. The first question is, okay, like, show me what they're asking for. Right? Show me the email they sent. Show me the chat message. Right? Because then I need to know what they actually want now. Similarly, if you're in a hospital, okay, and you need to do any kind of patient risk prediction, any doctor would come in and say, okay, show me the notes. If you have a patent dispute, a lawyer would come in and say, okay, show me the patent. Right? Show me the lawsuit. Of course, you can get some hints from who is prosecuting and what kind of company it is and what time of year it is. But really, what you're looking for are cases where you have a simple baseline model with structured data, but in a sense, it's obvious that a lot of the interesting business context to solve the problem is within the text. So those are the problems that you'll probably get the best benefit from using NLP or using an NLU. So definitely recommend you start there. And when you set expectations, so when people ask you, and this is kind of one of the first questions you will get, is how accurate is this going to be? Really, there are two things to know. So the first thing to know is the good news, which is that if you really have access to state-of-the-art deep learning, machine learning, reinforcement learning, NLP libraries, so you have access to those data scientists, and you have access to high-quality labeled data, you can definitely match or beat human experts. And I would say today, in most problems, if the problem is specific, you have good data, current algorithms would enable you to do that. And this is really why machine learning and AI are kind of taking on more and more of those tasks within our world. So that's, I think, a valid expectation to set. And I know we've been able to deliver on it fairly consistently over the past couple of years. The bad news is that doing as well as humans do is often not very accurate. Okay, and often algorithms are held to a different standard. So what would happen is that, for example, this happens. I'm familiar with the medical space. Radiologists, pathologists, doctors would have accuracy rate of anywhere from 80 to 90%, right, in terms of how correctly they actually diagnose. Okay, and it's similar with lawyers. It's similar with customer service agents. It's similar with a kind of like executive assistants. Okay, that you have this 10 to 20% error rate that humans make. Okay, for a variety of reasons, which is okay for humans, but not that good for not acceptable when computers have those mistakes. Okay, so one expectation I want to set is kind of say, yes, look, we can probably do as well as our expert humans in this case. But look, if our expert humans are giving you right now, 75%, okay, which is, for example, that's actually on the very good end of looking at brain scans, okay, and diagnosing and making diagnosis out of brain scans. then maybe an algorithm can get to 75%. It's not going to get to 95%, not based on the data on the current state of the art technology. Okay, so that's really the second thing that you want people to understand, because people sometimes just in a sense do not see the errors that are already there in the system and expect new systems to have this kind of perfect accuracy. So, as a summary, three main things you need to know when you start your own natural language understanding project. One is there are many, many languages that we speak as humans on a daily basis. And if you're looking at a specific business problem, business context, it will probably translate to a different language that your models will need to learn. Second thing, in terms of how you go about it, you will need a real data scientist that understands NLP, because you probably need to build your own domain-specific model. You will need domain experts who can give you high quality and consistent label data, and make sure you have enough data to actually build those models. And that should be the core of your project. And the third thing is do plan to use structured and unstructured data as well. Okay, and in many cases, the simplest way to start is build a really simple model from structured data, and then start adding NLP features you extract from the text to see that you can improve the accuracy of that model. So those are kind of the three things that I want to go over. If you have any questions, feel free to write them now in the questions from audience section. And we have a few minutes to take questions now. And I'll say in general, if you have questions, you're welcome. And you have my email, social media here, and you're welcome to get in touch. Afterwards, I'm always interested to know what kind of projects people are doing, what things are working, and what's not working. So that would definitely be interesting for me to discuss. So I'm going through questions here. Okay, so there are two interesting questions here that are essentially around transformer learning. So I'll see if I can answer them together. The question is there any way for an NLP algorithm or model to review reference material to infer context for different language or jargon or context? Because this is really how humans learn. So for example, the way people learn to read legal language, right, is they go to law school and they sit and they read books of precedents, right, or contracts or patents or whatever kind of subspecialty within the legal field they have, and they learn the language that way, right? So so when they actually go to court or when they have to write a contract, right, they basically do this by example they've seen elsewhere, right? Similarly, the way I learn to read to read or write medical notes, I go to med school, then I go, to an actual hospital and I do some hands-on training, and over time, kind of, I learn the language that people use. Okay, and if you think about that's how we learn other languages as well, right? So the way I've learned to write kind of corporate email, right, when I was in that environment, is, you come in, people explain to you when you're junior, look, here's what you want to do face-to-face, here's what you do in emails, here are the right things to say in presentations, and here's kind of what's okay to do when we do when you use IM. And we learn those languages. Okay, we learn the vocabulary, we learn the meaning, we learn the insights and the assumptions in what's been said and what's not been said. So the question is, okay, is the way for NLP basically to read a whole bunch of text messages or medical papers, right, or legal contracts, and kind of learn the language on its own? And the answer is yes, to an extent. So definitely there's a lot you can do with unsupervised learning from text. You can build word embeddings, which are extremely powerful tools. And word embeddings are basically now used in all state-of-the-art NER, entity resolution, negation detection, spell checking models. So that's definitely doable, and that's kind of the easiest way to do it. There are also some real advances on most recent word embeddings in 2018, so projects Elmo and BERT, which are basically have learned to produce deeper contextualized types of word embeddings then not only look at the words around the word, but look basically at complete sentences or complete paragraphs. So that's definitely one thing you can do. There's also a kind of information retrieval techniques when you can start learning a corpus. For example, you think about computers can read the entire body of biological research, and then there's a lot of work right now, things like question answering from those contexts. So that's another thing you can do. And I'd say we are definitely doing as much as we can there. Right now with the technology we have, it's a mixed bag, right? So there are some things where we can do via this kind of unsupervised transfer learning, but then, usually if you want to answer specific questions within a specific context, usually the right path is to go and label data for UKs and do it that way. But I would definitely say that, especially I would say in the past year, most of the projects we've had use the combinations of both techniques. There's another question here about other languages and how you kind of deal with really moving between different human languages. So what's happening is that there's a lot of work. So kind of the work in the NLP kind of it's correlated to the popularity of the languages. So there's most of the work is on English. Then I would say after that there's a lot of work on Chinese. After that there's a lot of work on kind of the Latin languages. So Spanish, German, Portuguese, French, Italian. And then kind of there's a whole set of other languages, so Indonesian, Russian, Urdu, Arabic, really based on the populations that are speaking those languages, right? And it's kind of correlated with the economic opportunity there. In general, many of the algorithms that you use to learn a new domain, so take something, for example, from a customer service context to a legal context, basically use the same techniques to train for a different language. So in a sense, let's say if you want to understand Spanish, you need to train a different tokenizer, different lemmatizer, different part of speech tagger, different dependency parser, different NER. Most of the algorithms, in most cases today, you can actually use the very same algorithms and kind of training pipelines. And if you give it different training data, either supervised or unsupervised cases, you would get the models. So usually the problem is really much more about just getting good label data in all of those languages, in contrast to actually finding the models or finding what works. But I would say today supporting different languages really it's work, because in many cases those models, they're not open source, they're not readily available. But in a sense, it's become less of a challenge. I think a lot of it is because this understanding that even if you only think you're doing English or you're only doing Chinese, you actually need to support many different languages, which means that your libraries need to give you powerful training pipelines to do that. So if you have the data, you can fairly easily migrate. Okay, so this is, I believe, the time we have. Thank you very much for listening and joining this webinar. Please, you're welcome to keep sending questions or provide feedback or connect with me after the call. Thank you, and I wish you the best of success in your own projects. Thank you.